Alright guys, let's do some more examples of implicit differentiation. So here's the first one. We have y squared equals 3x plus 1. So what we're going to do is we're going to differentiate this guy by doing d over dx on both sides. So remember, let's do the right hand side first because it's easier. So remember, d dx of 3x plus 1 is just 3, right? This guy's linear, or you can use the power rule, however your brain works. Now for the left-hand side, we want to do d dx of y squared. Now y is an implied function of x. So what we're going to do here is we're going to pretend like y is just x and differentiate him normally. So I would get 2y as my derivative, but because it's y, our variable here is y of x and not just x, we're going to attach a dy dx here. So that's really the key of this whole thing. Anytime you differentiate y, just attach a dy dx to it. And remember, our goal here is to find dy dx, so we're just going to do some algebra. Let's put, we're going to put 2y on the other side. And we get 3 divided by 2y. Alright, so let's do another one. And I didn't write these out, I'll write them with you. So example, x plus 3y equals 1. So I'm going to take the derivative on both sides with respect to x. So 1 equals big bracket. Okay. And now I'm just going to take the derivative. I'm going to use like the distributive law, and I'm going to take the derivative of each of these terms. Let's start with the right-hand side of the equal sign. The derivative of a constant is just 0, so that guy will become 0. So equals 0. D dx of x is just 1. D dx of 3 times y, just pretend y is x. So if we had 3x, our derivative would just be 3. But because we took the derivative with respect to x and we had y, using the chain rule, we have dy dx. And again, we're just going to use some algebra to solve for dy dx because that's what they want. Find dy dx. That's the question here. So I put 1 on the other side, and then I divide by 3. There's our answer. All right, let's do another one. Hopefully you guys are getting this. It's pretty straightforward. Just pretend like y is x, and then attach a dy dx next to it. So here's the next one. I hope my clicking of this pen is not too loud. That's kind of why I write everything before the lecture. And what did I do here? I can't even tell what I wrote on this paper. Oh, equals 1? Yeah, equals 1. Not equals 1. Equals y plus 1. There we go. Okay, so let's do d dx of both sides equals d dx of y plus 1. All right, let's do the right-hand side first. So d dx of 1 is just 0. D dx of y, if we pretend y is x, we get 1. But because it was y using chain rule, we have dy dx. Okay, so that just leaves us with dy dx on the right-hand side. On the left-hand side, we have x times y squared. Now, we can't split these terms up. What we're going to have to use is the product rule. And if you guys remember, what the product rule says that d dx of f times g these are both functions, f and g, then the result will be f prime times g plus f times g prime. So what we got to do here is we got to take, geez, my computer's freaking out. Okay, we're going to let f equal x and g equal y squared. So then f prime equals 1 and g prime equals 2y if we pretend like it's x, and then attach a dy dx to it using the chain rule. So let's put this together then. So on the left-hand side, we'll have 1 times y squared plus x times 2y dy dx equals dy dx. And now, what we have to do is remember what we're trying to find. We're trying to find dy dx. dy dx. So we have a dy dx here, and we have a dy dx over here. Let's see if we can combine them. So let's just use some algebra. I have y squared equals, let's get this whole term to the other side, dy over dx minus 2 times x times y. I just put the x in the middle right here, times dy dx. And now what I'll do here is I'll have y squared equals, I'll factor out this dy dx, and what I'm left with once I factor this dy dx is 1 minus 2xy. I factored out a dy dx, and now I can easily solve for what dy dx is. So that means dy dx is equal to y squared divided by 1 minus 2xy equaling dy dx. So you guys see it's very simple. See, to do a lot of these things, to actually do the computation is very easy. The hard part is understanding the concept and what's really happening in the background. But if you're not a math major, or maybe this is the only math class you have to take for your major, you're not going to be using math in your job, hey, just know how things work. However, if you are going to go on to higher level maths, I would take a second to understand the concept behind everything, maybe use some outside resources. There's a really good video. I reference him a lot. If you look at my lectures, I use a lot of his examples. There's a guy on YouTube called 3 Blue, 1 Brown. He is amazing. And I steal a lot of his examples because he just makes it so easy. But anyway, let's do one more. This was the answer, by the way, for our last question. Alright, so we have 3x squared y minus 4y squared x plus 7 equals 1. And what we're going to do is we're trying to find dy dx. So we'll take d dx of both sides. So d dx of 1 and d dx of 3x squared y minus 4y squared x plus 7. Okay, let's do the easy ones first, okay? So if I distribute this guy across, I get the derivative of a constant and the derivative of a constant over here. So both of those terms equal 0. So we can just fill that in right away. So all we're worried about right now are these two terms, this guy and this guy. So unfortunately, those are products. So we got to do chain rule product rule 2 times for both of them. So let's attack this one first. Let's attack 3x squared y. And let's let f equal x squared, g equaling y. So therefore, f prime equals 2x. I took the derivative of this guy. And then g prime, the derivative of this guy, will be 1 dy dx. Because I'm taking the derivative with respect to x. Okay, so let's piece together this guy's derivative. Notice how I didn't include the 3 in this, because I can always say d dx of 3x squared times y. I can always just pull out this 3. You can always pull out a constant when you're doing multiplication. So what we'll have is we'll have the product rule here all multiplied by 3. So what we're going to have is we're going to have 3 multiplied by the product rule, which is 2x times g plus x squared times dy dx. Okay, we're not going to have enough room here. Okay. Then we'll have a minus 4 out here. So now we want to take the derivative of this guy, minus 4. How do I write it? Y squared? Y squared times x. So this time, f will equal y squared, g will equal x, so f prime will equal 2y dy dx, and g prime will equal just 1. So let's piece them together. We get y squared, sorry, let me just keep the same order. 2y dy dx times x. Oh my gosh, we're running out of room here. Plus g prime, which is just 1. And what do we have there? Just y squared for f. Wow, this is an annoying problem. Okay, equals 0. So let's just simplify a little bit here. So I'm going to distribute this 3 to each term. So I'm going to have 6xy plus x squared dy dx minus, now I'll distribute this minus 4 across, minus 8xy dy dx minus 4y squared, all equaling 0. Okay, so this is what we're working with here. Remember, our goal here is to isolate dy dx. We're trying to get these guys, we're trying to make them into one term and then isolate them. So probably the plan of attack here is to put anything with dy dx on the other side and then factor it out. So what we're going to be left with is 6xy minus 4y squared equals minus x squared dy dx plus 8xy dy dx. So I put both of these guys, I just brought them to the other side. Okay, so now I'm going to factor out that dy dx. 6xy minus 4y squared equals dy dx plus 8 xy. And now we'll just divide. So we get dy dx equals 6xy minus 4y squared over minus x squared plus 8xy. All right. And this is just the same process over and over. If they want you to do product rule, use product rule. If they want you to use power rule, use power rule. If they want you to use quotient rule, do quotient rule. So it's kind of the same stuff. Just the only thing that they want you to know is that anytime you differentiate anything with a y in it, anytime you do anything with a y in it, just treat it like it's a normal x, but then attach dy dx next to it using the chain rule. And if you forget why we do that, just come back to this example that we did in the previous lecture, in the previous video, and hopefully it all makes sense. All right, next class, or next video, we're going to be doing some applications of implicit differentiation, and that is actually the hardest topic of the semester. It can be a little confusing, so we're all going to put our thinking caps on. All right, see you then.